Now I will explain the stage assessment. So number one, let x1, x2, and up to x5 be samples from population. X follows the binomial distribution. So for binomial distribution, there is only yes or no. Okay, this way. There is only two parameter, yes or no. And I have shared a note about what is binomial distribution and what is the conditions. So I'll share, I'll open here. Distributions. This is binomial distribution, and the properties here are we have only two potential outcomes. So it can be either yes or no, it can be true or false. Okay, so we will have only two potential outcome, and the probability of success is the same across all trials. So for example, if I flip a coin, I'll get head or tail, right? So getting probability of getting head is 50%, and probability of getting tail, it is also 50%. So that means binomial distribution, it has only it has the same outcome. Okay, and then the number of trials is already fixed. So I mean, if I flip the coin two times, it is the number of trial. Okay, so we tell it, we represent it as n, and each trial is independent. Independent means if I flip the coin for the first time, it doesn't affect the second time if I flip the coin. Okay, so independent means the first event doesn't affect the second event. So if I give you another example, if I have three pen, let's say red, blue, and green pen. Okay, red, blue, and green. So if your friend takes the red pen, then the next event, you cannot take the red pen, right? So this time the first event affects the next event, but for independent, when the event is independent, then the first event will not affect the next event or afterwards. Okay, so now let's come back here. X follows the binomial distribution 1 and P. Write the joint distribution law samples. So here, the joint distribution law is here, right? P of I equal to 1 from 1 to 5, because we have here from 1 to 5 in the question here. In the question here. We have x1 to x5, right? That's why we write here probability of summation I from 1 to 5. Okay, so what do we say? Yeah, we sum the xi value, right? Xi. So here is the probability, and on minus p. This is the one. We know that in probability, on is the total probability, right? The value of probability is from 0 to 1. So if p is the probability, so then 1 minus p, this is the remaining part, right? So 1 minus p, and then 5 minus summation I is equal to 1, and we sum it up to 5, right? Like x1 plus x2 this way up to x5.
Omar.
Yes.
Can you explain this again? Where can we get that 5?
Okay, so this 5 is the number here. Okay, 5. As you see, we have
x5
from x5, right? We have from 1 to 5. Okay, and then
I see.
the I value here is 1. This is I value, okay, 1 and 2, and this is 5. So we write down here 5 minus I equal to 1 to 5, okay? And what we sum,
Okay.
the summation of xi, that means we sum x1 plus x2 plus x3 this way, okay? Up to then x4 and x5. This summation means this part. And then here xi will be 0 and 1 because you see here xi, right? 0 and 1.
How can we calculate it?
Yeah, this means binomial distribution, okay? Either 0 or 1. Okay? And then here our value of I is from 1 to 5. 1 to 5. So this is just nothing. It's just, I mean, a simple notation.
Oh, wait. How can we calculate it?
Oh, here x equals 0, 1.
This. How can we get that result?
Okay, wait.
আসেনি পড়তে
No.
আসে
XI, right? Joint distribution law. P. Okay, so I think here we know that probability is from 0 to 1, right? This is the probability value. So it is just, we don't calculate it, we just write down it like 0, 1, maybe. Okay? Maybe, I'm not sure.
Okay. It's okay.
But let's continue and
Okay,
we
go
will
on.
try to come back here again, okay? If we get some
Okay,
problem later.
Okay.
And this is
Go on.
joint distribution law, okay? So remember this one, joint distribution law. And now the second question here is, suppose that the sample observed value of capacity n equal to 10 are here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And calculate sample mean and sample variance. So here is s square. We can also say it as sigma square, okay? Sigma square. So we know that sample mean x, it means we have to sum all the xi values, right? We have to sum all of them, 8.2 plus 7.9, we have to sum them. And then we have to divide by the value of n, or total number of events here, right? So total
Okay.
data. So here n is equal to 10. So we sum them and we just divide by 10. So we get 8.23.
Okay.
And the sample
So
variance.
this is the formula.
Yeah, it's like the very
Okay.
basic formula of finding the mean. Just add them and divide by the number.
Okay.
So here we have 10 sample. So we divide by 10, okay? Here n is equal to 10.
Okay.
And now the sample variance is square. It is here is the formula, 1 by n minus 1. And then we try to find the as you see this 8.2, 7.9, all these separate data, they are called xi, okay? It can be x1, it can be x2, 8.4, it can be x3, okay? So we try to find and x bar, it is the mean. So we try to find, let's say here is the mean, right? Let's say it's a graph, and here is the mean. So mean is sometimes mu, okay? Mu, or sometimes it's x bar. So it depends on what kind of data are you are working with, or what kind of distribution you are working with. So here is the mu. So we try to find how far. Let's say data is here, is maybe 0.5, and we try to find how far it's from the mu, okay? How far it is from the mu. So this is this part, xi minus x mean, then whole square. So here's number 2, right? Number 2. Yeah. So sample mean, okay, sample variance. So if I try to calculate it, like it will be, here mean is 8.23. So 8.2, sorry, 8.2 minus 8.23, okay? Then whole square. So why we use whole square? Because if we get a negative number, it will become positive number, okay? You know, -2 square, it will become 4, right? So here a square, it will convert this number into positive. It will convert this value xi minus x mean. It will convert this value into a positive number, okay? And then again, 7.9 minus 8.23, 8.4 minus 8.23, okay? This part means this way, xi minus x bar. It means here it is xi, that means x1. Here it is xi, that means x2, okay? So x1 minus mean, that means 8.2 minus 8.23, 7.9 minus 8.23, okay? And then we make the square, so that all the the value here becomes positive. So then we sum them. You see here summation sign. We sum all of them, and then we divide by n minus 1. So here n is equal to 10, right? So we divide it by 9, okay? We divide it by 9. Then the answer will be 0.169. This is a sample variance, right? So I haven't explained here. I haven't detailed explained here, but it is calculated this way, okay? So it will take much time. It will take some time to calculate using my calculator or using my hand. So I think you understand, right? Xi, that means 8.2, then minus 8.23, then whole square, okay? And then plus 7.9 minus 8.23, then whole square. So this way you have to add this 10 number, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And then you divide by n minus 1, so divide by 9. You will get the final answer here, the sample variance. And to make the calculation simpler, maybe here in Google, you can find some online calculator maybe, so that it may, yeah. This is.
But I think I need your help to calculate it.
Yeah, no problem. I'll be there. Sample variance. So let me share my screen and I'll show you. So can you see my whole screen now? So we have some value here that is, could you please spell it out for me and just I'll write down them here. These numbers, just tell this number 8.2, 7.9, 8.4. Okay, let's do it side by side. So for variance, the value here is 8.2, 8.2, 7.9, and then 8.4, 7.6, 7.6, and 8.9, 8.5, then 8.6, then 7.7, then 8.4, 8.1. So we calculate this part. So the variance is 0.169. See here, 0.169, right?
Okay.
So you can also use this calculator to find the sample variance. So I will share this link with you, and And do you still remember the phi value of phi? So here is phi. Let me sure. So this is the link where you calculate phi, okay? Let's say phi of 0, but Laoshi will give the answer. So phi of 0 is 0.5. Let's say phi of 1. It is 0.841134, okay? So Laoshi will give us the value of phi, but you can also get them here, okay? If you need some, if you need. And now let's continue from here. So I think this one is clear, right? Number 3, let x1, x1, x2, and x25 be samples from the population. X follows normal distribution. So here it is sigma, this is mu, and this is sigma square, okay? For normal distribution, we get the first coordinate here is mu, and the here 2 square, it is sigma. Find expectation of x mean and variance of x mean, where x follows. Okay, so we have to find expectation of x mean and variance of x mean. So x mean, number 3, right? Okay. So as I have written here, this 25, this is the number of samples here, right? Number of samples from x1 to 25. That means we have 25 samples. And then here you see the value x mean follows the normal distribution. So E of expectation of x bar, expectation is also represented as mu, okay? So mu and expectation, they are similar idea. And here you see the standard deviation sigma. So sigma and dx, they are some similar idea, okay? Say sigma and dx. You know that sigma square equal dx. Yeah. So sigma equal to root over dx, right? So we can say that sigma and dx, they are some similar idea, and mu and ex, they are also some similar idea, okay? So here we get expectation of x mean. So the data is already given 75, and expectation and the variance, D is for variance. So variance of so here the variance of x mean, it is 2 squared by 25, okay? And now we just calculate it here. 2 squared by 25 is 0.16 maybe. 4 by 26, 25. Yeah, 0.16. So this is the answer. Number 4. Investigate the degree. Yeah, it's not difficult. Investigate the degree of certain pests in a wheat field. If 8 sample points are selected, 1 meter square is specified for each point. The measured number of pests is here. So we have some data, the measured number of pests, and write the empirical distribution function of the pest population based on the samples. So you have to write the empirical distribution function, right? Okay. So the empirical distribution function of the population here, how do we find this? Okay. If you look here, the data, we have 0 here, 2 here. So we just plot them, we just rearrange them, okay? 0 and 0 and 0, and maybe 1 and 1 and 2 and 2 and 3, right? We just rearrange them. And now if you see here, now we have to draw this line, okay? Real line, this line, real line. And we plot this number 0 and 1 and 2, okay? We plot this number here, 0, 1, 2, and 3. And now when we start from the left side, we have 0 here, right? So from 0 to the left side, we go to the left side. So when we go to the left side, here is no value, right? So the distribution function here will be 0. And then you start from 0. You see here the equal to sign. You start from 0. That means you have to take the value when here is 0. So, and it ends before 1, okay? It doesn't include 1. See here, it is not less than or equal to, it's just less than. That means it doesn't contain the value 1, but it contains the value before 1. See
Plus
here,
1.
this part, yeah, this part. So before, previously we had 0, and now, as you see here, how many 0 here? Here is 1, 2, 3, right? Here is 3 0. And how many numbers in total? 1, 2, 3, 4, 5, 6, 7, 8. So we have here total 8 number, right? 8 number in total, and we have 3 0 here. So that's why it is 3 by 8. And now we now the next part we include 1. You see here the equal to sign. So now we include 1. X is greater than or equal to 1, and x is less than 2. So when x is greater than or equal to 1, so we already got 3 values here, right? You see here. We have taken this 3 value already, right? And now we have to include 1.
Right.
So 1 is here, 2 1 here, right? So 3 plus 2. Now we have total 5 numbers, right? 5 numbers. That's why here the answer will be 5 by 8. Okay.
Okay.
And now now we will include the number 2. You see here, x is greater than or equal to 2 and less than 3. So it's from here, right? It's this part. This part. So when x is when we include 2, so again we add this. So we get 2 here, right? So in total here is 2 and 2, 4, and then 3. So 5 plus 2, then we have 7. We have 7 numbers in total here. So it is 7 out of 8. And when we think of x is greater than or equal to 3, that means we take all these, right? We take all of them.
8 by 8.
So this is called total probability. So total probability is 1. Okay.
Okay.
So the first one here will be 0, and the last one here will be 1. You can write them without calculating. And this part, this 3 part, you have to calculate. Just use just the summation, right? It's not very hard. And now let's see number 5. Let the distribution law of x be here, and the value of theta is from 0 to 1 is known parameter, is unknown parameter. Known the sample values are here x1 equal to 1, x2 equal to 2, and x3 equal to 1. Okay, we have some sample value and we have a distribution law. Try to find the maximum likelihood. So here is maximum likelihood. So what does it mean? Let's say likelihood means probability, okay? Likelihood is the similar concept as probability. There's some difference, but they're similar, okay? So you can think of it's a probability. So maximum likelihood means where is the top? Where is the top of this graph, okay? So let's say if we have a distribution this way, so our top point is here, right here. And it will be the maximum likelihood, okay? And if you find the derivative here, you see here we have 0 degree, right? And we know that derivative m is equal to tan theta is equal to tan. Here the angle is 0 degree, right? So tan 0 degree. So tan 0 degree will be 0, right? Salam. Yeah. So here the derivative will be 0 degree. So we have to find that derivative here, right? For the first question here. So to find the maximum likelihood, it means to find the derivative at here, okay? And the derivative will be 0. So now let's say see here how I calculate. Where is the question? So you have to find the maximum likelihood estimation of parameter theta. So firstly, we find the likelihood function, okay? And then we take the logarithm, and then we make the derivative. You see here, we calculate the derivative where the derivative is equal to 0, right? So here to make the calculation simpler, we firstly find the ln of likelihood function, and then we find the derivative with respect to theta, and then we write down it equal to 0. Okay, and if you just do some simple algebra here, then you will find the value of theta. Okay, so the theta is 5 by 6. It's clear? Maybe not so clear, but I will try to explain the first and the second part here. Okay, so see here in my notes. You see x1 equal to 1, right? And here theta is from 0 to 1. So the first one here, this one, x1 equal to 1. So for x1 equal to 1, you see here x1 equal to 1. So the value is theta squared, right? So we write down here theta squared. And x2 equal to 2, that means here x2 equal to 2. So the value will be 2 theta into 1 minus theta, right? So I write down here 2 theta into 1 minus theta. And here again x3 equal to 1. So we take this this pk value. So here is theta squared. So if you multiply them, it will be 2 theta into times 1, it will be 2 theta, and then 2 theta times minus theta, that will be minus 2 theta squared. So, and then theta squared. Okay, so if you calculate this, I think you can, sorry, we don't calculate this way. You write down 1 minus theta separately here, okay? 1 minus theta separately here. And we have theta squared, and we have theta 1, and we have theta squared. So in total, it will be 2 and 1, 3 and 2. That means 5. Theta to the power 5, okay? And this 2 is here. So this way you find the likelihood function, and to take the logarithm, just simple here, also simple steps. So you see theta squared. So for theta squared, the ln value, we just take the power down. So the value will be ln 2. And then 2 theta into 1 minus, oh, sorry, here, not here, not there, here. See, we have 2 times theta to the power 5 into 1 minus theta. So if I find the ln of 2, this is the first number here, it will be ln 2. And then we have theta to the power 5. So we have to bring the power down, okay? We have to bring the power down. You see here, I bring the power down. So I get ln theta. And then here is 1 minus theta. So I write down here 1 minus theta. Okay, so this is the logarithm of likelihood function. And then you just find the derivative of, okay, so you just find the derivative of this part, the logarithm, okay? So you know that ln 2, this is a constant, right? Ln 2 is a constant. So derivative of this constant will be 0. And 5 ln theta, we know that derivative of ln theta is equal to 1 by theta, right? And we have a constant 5 here. So we write down here 5. So 1 multiply 5 is 5. So it is 5 by theta. And then derivative of ln 1 minus theta. So we know that this is the chain rule, right? We expected theta here, but here is 1 minus theta. So firstly, we treat it as something else like c. So derivative of ln c, it will be 1 by c, right? And then we calculate the inside part. So you know outside inside rule. So derivative of 1 minus theta, it will be minus 1, right? So that's why we write down here minus 1, and then here c. C is 1 minus theta, right? We let c equal to 1 minus theta. So derivative of ln 1 minus theta, it will be minus 1 by 1 minus theta. So Grace, do you understand? This is just a derivative calculation of ln of the logarithm here. Do I need to explain? Yeah, I have given the notes here, right? Ln 2 is constant, so derivative of constant is 0. And we know that derivative of ln theta is 1 by theta. And we have a constant 5 here. So we multiply 5. So 5 by theta. And derivative of ln 1 minus theta, this is, so you see, we treat this as a constant. So derivative of ln c, it will be 1 by c, right? So 1 by c. So here c is 1 minus theta. right? So, and then we calculate the inside part. Inside we have 1 minus theta. So 1 minus theta. We find the derivative with respect to theta. So 1 is a constant here. So constant derivative of this constant will be 0, then plus, minus derivative of minus theta. So we know that here we are doing, we find the derivative with respect to theta. That means the derivative of minus theta will be here, minus 1, okay? So the answer is minus 1 by C. So here C is, we let C is equal to 1 minus theta, right? Here, 1 minus theta. So we substitute the value here, C is 1 minus theta, okay? So this way you calculate the derivative. And so parameter, maybe this is just some formula, okay? There is nothing fancy here. So maybe I have to in here because my students are waiting for me, okay? Chris, I think you understand. Just review my video, okay? They're pretty
Okay.
simple. They are not so hard. If you just review my video, and if you come here, you will probably understand all these parts. And again, if you have some problem, you can knock me. Maybe we covered most of the parts. My students are waiting, so I have to in here, okay? So don't mind.
Okay. Oh, where are you?